Before starting this proof, f is equal to r by 2, we have to discuss a bit of geometry. Actually, this is geometrical optics or ray optics. Ray optics, and this ray, light ray, obeys all the geometrical rules, mainly Euclidean geometry. So before starting this proof, we have to discuss a bit of geometry, concept of geometry, and then we shall proceed. Suppose this is a center of this spherical body. Actually, this is spherical body. Okay. So center of the spherical body, we have taken a cross section here. This is another cross section. T prime, particularly this line, T prime is a tangent at point M. So this point is M. Now we know if we draw a line from center to the point M, then it will be termed as radius of this circle or this spherical body, both. So R is equal to Cm. R is equal to Cm. R is equal to radius of the circle, and T prime is the tangent, and we know from our geometrical concept that Cm is perpendicular to T prime. Okay, actually tangent and radius are perpendicular to each other. It is your concept from geometry. Now, if any ray like AM is a light ray, and the direction of the light ray has been shown in this figure. Any light ray from point A that is incident on M, and if this point M can reflect that light back. That means if we consider this spherical body like this, the outside of the spherical body is silvered, and inside of the spherical body is a plane surface. It may be made of glass or any metallic surface. Actually, this is the point of incidence of AM light ray. So we can say AMC is theta is equal to angle AMC is the angle of incidence. And if AMC is theta, then we can say CMB, this point is B, it is also theta. Theta is equal to CMB. We may say theta prime, then theta is equal to theta prime. Actually, angle of incidence is equal to the angle of reflection. That means when the light ray AM is incident on the point M, it will pass through a fixed point like this, F. F is the fixed point on this line, CX. CX is the line. So, F is a fixed point, and the reflected ray passes through point F. Actually, CM is the normal at point M, That is why the angle of incidence is equal to AMC and the angle of reflection is equal to CMB. And these two angles are equal according to the rule of reflection. Okay. So this bit of geometrical knowledge is necessary to prove this principle. F is equal to R by 2. Here F means F is equal to focal length, and R is equal to radius of curvature, radius of curvature of this surface. Every circular surface, this surface is, it is a curved surface actually, and this is a perfect circle. So every curved surface have a fixed center of curvature. So it is the part of this particular mirror as shown in this figure is a part of a spherical surface, and as it is a part of a spherical surface, it must have a center of the circle, and any line drawn from the center of the circle or center of the spherical body up to the periphery will be treated as the radius of curvature. So we can say Cp is equal to R. Cp is equal to R. R is equal to radius of curvature. And Pf is equal to Pf is equal to distance of the focal point from the pole. Pf is equal to F is equal to focal length of this curved surface or concave mirror in this case. Okay. Now, this light ray, particularly this light ray, is incident on the mirror at point M and reflected back from the point M along the direction as shown in the figure. So this arrow and this arrow mark indicates the direction of the light. And from the previous principle we know that this is the angle of incidence theta and this is angle of reflection again theta. Now as the principal axis actually x prime, this line is the principal axis, and on the principal axis there is a point that is called pole. So the light which is parallel, the light ray which is parallel to the principal axis will pass through the focus. This line, the line of incidence or incident ray, and the principal axis, these two lines are parallel to each other. So we can say this angle, that means MFD or MFP, this angle is 2 theta. Actually, this angle is equal to this angle. It's an alternate angle. So when this is theta and if this is theta, the total angle is 2 theta. So we can say MFD or MFP is equal to, actually D is the foot of the perpendicular. D point is the foot of the perpendicular drawn from M to D. When for a particular shape of this curve, for a particular shape of this curve, P approaches to D. That means we can say D point D tends to P. That means D and P, though 2 points are separated here, these 2 points are treated to be a single point. Okay. Now, from the geometry, we can say tan theta is equal to MD by CD. Look here, tan theta. If this angle is theta, then we can say this angle is also theta. Okay. So we are writing here, suppose this is point A. So angle AMC, angle AMC is equal to theta. This is angle of incidence. And CMB, angle CMB is equal to theta is equal to angle of reflection. Okay. Now we have to prove actually F is equal to R by 2. So this part particularly, this part should be abolished. We need this space to prove our actual principle. Okay, this is enough. Okay, so tan theta is equal to MD by CD. MD by CD. This is MD and this is CD and this angle is theta. Similarly, tan 2 theta is equal to MD by FD. MD by FD. For small theta, when theta tends to 0, that means the value of theta is very small. Or for small theta or theta tends to 0, tan theta is equal to theta and tan 2 theta is equal to 2 theta. So we can say this is equal to theta and this is equal to 2 theta if theta tends to 0, otherwise not. So MD by CD is equal to theta and MD by FD is equal to 2 theta. From these two equations, 1 and 2, from 1 and 2, we have 2 into MD by CD, 2 into MD by CD is equal to MD by FD, MD by FD. That implies from this equation, FD is equal to CD by 2. FD is equal to CD by 2. And previously we have said that D tends to P. Actually, D tends to P for a particular shape. For a particular shape of this curvature, D tends to B, D tends to P, D tends to P. So when D and P are not separate lines, separate points, these 2 points are identical and only single point, then we can say FD is equal to FP. That implies for this particular shape, FD is equal to approximately FP and CD is equal to CP. Is equal to CP. So FD is equal to FP and CP is equal to CP, or FP. FP means the distance of the focal point from the pole, that is equal to F. So F is equal to CP means CP, the distance of the center of curvature from the pole, CP, and it has been considered to be equal to R. R is equal to radius of curvature. So F is equal to R by. So this is all about this. F is equal to R by 2. Okay. So this is the most fundamental proof of mirror equation. Next, we shall prove the mirror equation in next class. And to prove that, we have to remember this equation. Now, one question may arise. This is true. Actually, this principle F is equal to R by 2 is true for a concave mirror. For convex mirror, it is also true. If we draw a convex mirror like this, in case of convex mirror, picture will be like this. This is the principal axis. This is the incident ray. And this is the reflected ray. This center of curvature, actually this surface is curved in opposite direction. So the center of curvature is this. If you draw a line from center of curvature on this point, then this line CN like this will be the normal at this point, and this is angle of incidence, this is angle of reflection from the principle of geometry. We can say this angle is 2 theta and this angle is theta. In this case also, tan 2 theta is equal to MD by CD. MD by CD. In this case, this is the focal point and this is center of curvature. So distance from P or D, distance from this is equal to F, or DF is equal to, in this case, DF is equal to nearly about, equal about df point D tends to P. Point D tends to P. This point and this point, these 2 points are, though these are drawn separately, for a particular shape of this curvature, it can be proved. This point and this point are identical. So PF is equal to DF. When D tends to P, PF is equal to DF, and that is equal to distance of the focal point from the pole, that is termed as AF, and DC or CD is equal to CP. CD is equal to CP. CP means the distance of the center from the pole, and that is equal to radius of curvature R. Now from this geometry, we can say tan 2 theta is equal to MD by CD. This is MD and this is CD. And tan theta is equal to MD by tan 2 theta is equal to, sorry, tan 2 theta is equal to MD by FD. This is the triangle. MD by FD. And tan theta is equal to MD by CD. Okay. Now from these two equations, we can say similarly, this is equal to 2 theta and this is equal to theta for a particular shape. Now, this two equation gives 2 into MD by CD is equal to MD by FD. That implies FD is equal to CD by 2. That implies when the point D and P are identical, then FP is equal to CP by 2, and that implies F is equal to R by 2. So this principal focal length is equal to radius of curvature by 2. This is true for concave and convex, both mirrors, and this principle will be applied in our next video. So you must remember this geometry or remember this principle to apply this knowledge for the forthcoming lesson, and this is the all about this principle. Now this video has been prepared in accordance with the book NCERT, page number 312. Actually, I am following the hard copy of the book, 312, page NCERT, class 12, part 2, or class 12, part 2. You may download this book from the internet or purchase the book from the market. It is very useful for book for all India examination. And at first we have to discuss the theories properly and then the problems. Thank you for watching.